Hi everyone, welcome to the next video. I did promise we were going to talk about correcting that function from the last example, but I forgot we need to do finding inverses first before we can do that, so that's what's going up next. So if you have a one-to-one function, finding an inverse is very simple. You start off by changing f of x and making it into y, and then the next step is the equivalent of switching the direction of the arrow, or in the example of ordered pairs, switching the order of the ordered pairs, is we're going to turn all the y's into x's and all the x's into y's. And then the next step, you may get stuck on depending on the problem. Anything I want to throw at you, you should be able to do. But if you're just looking at a problem, you find somewhere randomly, you may not always be able to solve for y, because, it can be very difficult to do. And then but if you can solve for y, because you've changed the position of the x and y's in the original equation, your y isn't f of x anymore, it's f inverse of x. And so instead, at the very end, you will replace y with f inverse of x. So let's look at a quick example, and then that'll be done, which is nice after that last long video. So we have f of x equals the cube root of x plus 2. So let me get a nice pen here. So what we're going to first do is step 1. So you're going to turn the f of x into a y. The next step is going to change the position of the x and the y. You're only going to have one y, but if you have more than one x, every x becomes a y. So the next step is to solve for y, and this one again is solvable for y. So I'm going to start off with the result of the last step, and I'm going to cube both sides. So let me do that in a different color. Show you that that's the operation I'm performing. So if I cube both sides of the equation, I get x cubed equals y plus 2, and then subtracting 2 from both sides of the equation, I get that x cubed minus 2 equals y. And then step 4 says that we take the y and replace it with f inverse of x. And there you have it. And remember that you have to satisfy this condition that f is originally a one-to-one function. If f is not a one-to-one function, you will not get an inverse. So that's it for this video. So now we'll talk about restricting domains in the next video, and I strongly recommend you understand that, because it will come back later in the semester, and you'll be saving yourself a lot of hassle if you understand the next video. So I'll see you then.